Please welcome Louis Douche and Robert Simon from Swiss Re. Louis studied applied mathematics in Paris and holds a master in industrial engineering from the University of Singapore. He is in the insurance industry for over 6 years now, working as a data scientist now with Swiss Re. Robert is a senior analytics manager at Swiss Re. He holds an MBA in business administration, and for almost 2 decades now, Robert works in various analytics roles and industries. Underwriting in insurance is a very complex business, especially in life and health insurance, where the injured objects are humans and we are known to be complex. So they have developed a guide helping underwriting that now gets more convenient using GenAI. And we hope that this thing certainly does not hallucinate. So please, Louis, Robert, GenAI developing and deploying a specialized underwriting AI assistant.
Great, thank you very much, Matthias, for the nice introduction. Hello everyone, my name is Robert, and before Louis and I will dive into today's topic, we're gonna give you a little context around the business challenges we faced, as well as the solution we have developed. For this, we have a short little video prepared for you, and we would like to play it back to you right now. Thank you.
Life and health underwriters face growing demands. Caseloads are high, and there is pressure to keep on top of medical advancements. At Swiss Re, we've asked ourselves, what can LifeGuide, the world's #1 underwriting resource, do to make underwriters' lives easier? That's why we've created LifeGuide Scout, LifeGuide's generative AI underwriting assistant, backed by a partnership of Swiss Re and Microsoft. With LifeGuide Scout, LifeGuide is even better equipped to help underwriters move forward in life with clarity and confidence. LifeGuide Scout will help them summarize large amounts of information in LifeGuide, provide quick answers to key questions, recall ratings in one seamless interactive flow. LifeGuide has been the market-leading resource for more than 30 years, empowering underwriters to meet growing demands with unparalleled depth of medical expertise. Join the future of underwriting. Let LifeGuide Scout take you forward in life with confidence.
Great. Now, with the context in mind as well as the solution, which is LifeGuide Scout, our generative AI product we just recently launched to our customers, we are going to jump straight into the first topic of today, which is the design of the RAG pipeline. And for this, I'm going to hand it over to Louis. Louis, over to you.
Thank you. Hi, everyone. So, as you can imagine, building such a bot is not just prompting an LLM, because this LLM hasn't been trained on our proprietary data. So we have to use this technique, retrieval augmented generation, RAG, to add a small step of information retrieval where we will enrich the prompt with the necessary information to answer the initial query. So there are many ways to do RAG. Here is how we do it for LifeGuide Scout. So when I go through this, keep in mind that we have 10 to 15 seconds to provide an answer, so we cannot go too crazy, too many steps, etc. So we start with getting a question from our user. And as you can see, it can be quite cryptic, filled with medical knowledge, medical words. So we have a first step where we reformulate this query. We expand it. We expand abbreviations. That's also a step where you can actually gather metadata to help you later in the retrieval stage. So this is a call to an LLM, but you could also have traditional machine learning to parse much faster this query. Moving on, with this expanded query, you can vectorize it. This will then enable semantic search in the retrieval stage. Retrieval stage, the objective is from this query and this vector, you collect the most relevant text chunks in your knowledge base, in your, I call it here, external data store or proprietary data, whatever you name it. And with this text, then you can craft your own prompt, where you set the persona of the bot, you give the instructions, traditional stuff, But then below this, you will add your question and the actual source that the bot should use. And we even ask the bot to actually tell us which text chunk is actually used to come up with an answer. And finally, you submit this to the LLM, and hopefully you get a useful answer. And of course, this can be repeated so that you have a sort of conversation with the bot. So going into more details with the vector database for the retrieval stage, at a high level, it's quite simple. You take your content, you partition it, embed it, add some metadata here and there, and put it in your database. In practice, what we saw, what was our guiding principle to create these text chunks was to create text chunks that are semantically homogeneous and self-contained, meaning if you take them separately, you shouldn't need to refer to other text chunks to get information out of it, and it should be quite similar in terms of topics. The second thing we had to deal with was tables. And tables is, you cannot keep tables as is, at least in our experience, because the retrieval stage won't handle it well. So that's where we generated summaries of these tables. You could also just put the raw text of the table, for instance, but you have to come back to text. And I think it's maybe a principle that I think is valid for RAG, is that you should separate the content you use for retrieval versus the content you use to put in your prompt. So now moving on to the retrieval stage, the logic. So as input, we have this expanded query, we have this vector. How do we come now to the most relevant text chunks? So we start with an easy step. We leverage our metadata. So we'll filter out all the text chunks that are not related to our query. So imagine you have a user originating from a specific market. Maybe not all your text chunks are relevant to the market of the user. So you can already remove a lot of candidates. Then in parallel, we do keyword search, where we find the most relevant text chunks with TF-IDF-like features. So that allows you to really put weights on exact matches, typically these name of disease. In parallel, we do a approximate nearest neighbor search, essentially the semantic similarity search using HNSW. It's a hierarchical graph algorithm. It's, I think, quite standard now in the retrieval step of RAGs, and we had good results with it. At this point, you have two rankings. So how now do you combine them into one? Well, we simply use reciprocal rank fusion. The idea is that you sum the inverse of the ranking for a given document. This gives you a score, and then you can reorder your documents according to this new score. After that, we have about 50 top text chunks, and now we want to even refine it more so that we can select the top 3, 4. And there we use a combination of natural language understanding models to further refine the ranking, the final ranking you get. So this was the core logic. Now if we move on to the real world implementation, how we did that, we expose our app as an API. So that's the center of it. It basically orchestrates all the steps I presented just before. So for instance, we retrieve from our content management system the user question. So you saw that in the video. Then we reformulate by calling, OpenAI in our case. Then we create the vectors. You could call an external service, or you could do it in server or having another endpoint, for instance. Then you do the retrieval part by querying your vector database, and finally generate again by calling the LLM. I would say optimization is key here, optimization of latency. So it may be really important to choose your cloud regions carefully, because some regions are overcrowded and really you can have peaks of latency. It's important as well to maybe own your embedding endpoints, meaning you don't rely on cloud providers. You fine-tune your own on your own text so that you fully control this service, and probably you will gain also on the retrieval side. And final step, asynchronous logging. We're still learning on this, so we have to collect a lot of information without impacting the logic. So that's why we have asynchronous logging. And typically, that enables us to do dashboards like this. Elasticsearch. We have these Kibana dashboards where we keep track of token utilization, for instance, and this can inform then your choices when you build your setup. So, for instance, do you go for GPT-4 32,000 tokens window or 8,000 token window? This was not necessarily obvious for us initially because it depends on usage patterns. And with this, I leave it to Robert.
Great. Furthermore, we wanted to create a trust-inducing user experience, and we did that so by adding citations to the application, guiding our users to the sources the LLM has drawn its answers from. You can see this nicely illustrated on the left-hand side picture. We also wanted to give our users a voice where they can let us know if an answer was incorrect and why it was incorrect. With this, in turn, we want to get enough data points that we can in the future improve our product. Last but not least, safety was of utmost importance. We wanted to make sure that LifeGuide Scout is not only a safe product to use, but also that it behaves as it's designed to. Now, why is this important, you may ask? Let me ask you, who in here has not heard of the incident Chevrolet had roughly half a year ago, where a user tricked a bot by selling him a brand new car for $1 US? Hands up if you haven't heard of this. Okay, I do see a few hands, more than anticipated. It is public, so you can definitely go and Google it later. But this is essentially the reason why not only if things go wrong can it have financial as well as legal implications, it can have a detrimental impact on the reputation of an organization or a company. We therefore applied internal governance frameworks and practices. We worked very closely with our legal team, but even more importantly, we did thorough adversarial testing through red teaming exercises, trying to jailbreak LifeGuide Scout to uncover risks and, of course, mitigate for those, ultimately making it a safer product to use. We're now coming to the final topic of today, which is the evaluation of the performance.
So we had a session just before about this topic, and so I'll start with the programmatic or quantitative evaluation. So how do you know that your setup first is good, and second, how do you test your new ideas? How do you know the next idea is better than the previous setup? That's what we try to do here, and it, like any machine learning model, it starts with having a good evaluation data set. So here we started going to the experts, asking them to create questions, answers, relevant text chunks, etc. That's really expensive. So instead, we generated it synthetically. So we started from the content itself. We asked an LLM to generate a question that could be answered with this content. And this way, we can gather a lot more samples, and then we go back to the experts and we ask them to validate and review these samples. Now, once you have a quality data set representative of the real-world question you expect, you can move on to metrics. What targets should you optimize? And there, I think there are two categories where we explored. First, metrics really that are about each step of your RAG pipeline, quite granular, so that you can already come up with a decent overall system. So I give the example, typically in the retrieval stage, we went for on the top right, we defined a sort of retrieval accuracy score, where we said, basically it gives the proportion of queries where we successfully retrieved the ground truth text chunks. So you can see that in 90%, if we retrieve 5 text chunks, we already reached 90% on this metric for a certain kind of content, which we call information here, but we saw that it's not yet there for another kind of content we have, which is ratings. So then we went back to the drawing board and iterated. So that gives you an example of how we iterated through small experiences. Then we also have to evaluate end-to-end. From the user, you get your output. How do you evaluate this? Well, it's not clear. Maybe you saw the presentation before. So we went for this paper, RAGAS methodology, which defines metrics along the things we mentioned before, the factualness, the context relevance, etc. And I give you here an example on the bottom right. So this is typically the prompt you would submit to an LLM. So yeah, it's an evaluation method. You ask an LLM to evaluate an LLM, which is strange, but if you have a better idea, let us know. So this prompt, basically, you add below the actual question and the relevant text chunks that your retrieval system has. So yeah, with this, you can start to count the number of sentences in your retrieved sentences that are relevant. Then you could divide, for instance, by the total number of sentences you have, and then you start to have a metric where you can compare across queries, across setups, and you can start iterate from here. Our experience is that these metrics are hard to rely upon. It's hard to use them in an absolute manner. Like if I've got 80% on this, it doesn't tell much. However, it's more in relatively speaking that it's useful. If you manage to increase it by 5%, it's generally a good thing. The other thing that was interesting, it's to look at the outliers of these metrics, because that's where you would usually find hallucinations or maybe issues in the way you index your data, for instance. Now, last piece of advice, of course, it's the fast evaluation turnover is really important if you want to test many ideas. That hasn't changed for machine learning, but it's a trade-off because these methods, RAGs, are really computationally intensive. And with this, Robert, go for the...
Not only did we validate our models the programmatic way, as Louis has just explained to you, we obviously also made sure that we have humans helping us to validate and test our models. We collected data via surveys to understand what is the overall impression of the product, but really gauging the usability of it. Will they trust the output of the LLM? Essentially gauging the adaptability. As mentioned before, we do collect user feedback directly via the application, where they can let us know if an answer is incorrect, and that in turn gives us an additional metric to gauge the accuracy of our models. But we also collect qualitative feedback, again, to let us know if something did go wrong, why did it go wrong, helping us, giving us enough data points to improve the product over time. Lifeguard Scout has been a tremendous success, and we truly believe it has been a success due to the factors we just walked you through today in our presentation, namely having a well thought through solution design as well as deployment strategy, but as Louis mentioned earlier, even more importantly, having evaluation methodologies or frameworks in place, helping the developer team to quicker iterate product and pushing it to market, but also giving us tools to test the quality and the output of the LLMs. We look very much forward to the future, and we will keep on innovating with generative AI, but we also want to stay vigilant and aware of real-world implications as during the presentation, as we have alluded to. With this, we are at the end of the presentation. Thank you very much for listening in, and we're now ready for your questions. Thank you.
Very impressive. Thanks a lot. Any questions? Yeah, I see lots of colleagues from the insurance industry. Go ahead.
Thanks for the great presentation. So you mentioned a lot of times you're measuring, you're checking how it's working, and so on. So what's the process of getting a new version out there, so changing the thing and getting it up and running? How are you doing it?
Yep. I can start.
Yeah, sure.
So I would say it's really feature-based. We have asked, our users want to see things. We try to produce the best we can, define our metrics, and release this. And then we collect feedback and try to iterate on these metrics we agreed with the business. Don't know if that answered your question or.
Sorry. So once you've collected the features and collected the information from the users, what exact steps do you need to do to get a new productive version out there? So do you have kind of a beta version and kind of a, or kind of a blue green testing or something like that? Yeah.
So I think here we have traditional software engineering practices, with CI/CD pipelines, dev, non-prod, prod, yeah.
Thank you for the talk. My question is, for the RAGAS evaluation, did you find that it's somehow important to use a different LLM to rate the answers, or are you using the same LLM that rates itself in a way?
So we're not using necessarily the same for typically the fast turnover. We use typically smaller LLMs to come up to a faster answer. And I think because it provides, the author of the papers used typically a smaller LLM, and it's a trade-off. Yeah.
Is it primarily because of the quality that it's sufficient with the small ones, or is it because you just want to be faster?
I think the quality is good enough, but mainly it's the speed. If we want to have an answer on whether our idea is good, is better than the previous setup or not, we don't want to wait like 2 days or depending on the number of samples you have to evaluate.
Thank you.
Question here, what kind of vector database did you use?
Yeah, so we didn't reinvent the wheel, so we're using already solutions by our partner, Microsoft. So you probably see AI search, these kind of services, which is really well packaged, I would say.
Because, I mean, the reason why I ask, because you said that performance is quite important when it comes to asking questions and getting an answer. Usually what I also hear from other colleagues is that they're struggling with a separation between the vector database and, for example, the operational database because of ETL processes in between. Did that have any effect on the performance on your end, or what's your evaluation there?
So again, we separate between environments. So we have a vector database in each, dev, non-prod, prod. So we can, grow increasingly confident about our deployment. Typically, we evaluate with internal users before going to external users.
Lots more questions in the back
Yep.
there.
Thank you for the presentation. Yep. I noticed an unconventional choice, I think, in the UX. You only had the thumbs down button and then the kind of the pop-up with the motivation, right? So I think this is different from, I don't know, ChatGPT or Gemini, the other ones. Can I ask you why do you go this way and if you see any benefit?
Sure, maybe I can jump into that one. So we worked obviously very closely with our UX UI designers, and maybe ChatGPT recently changed it again, but they actually also just do the thumbs down button, unless, again, it just recently changed. For us, most importantly, and also the logs that you've seen, we do collect all the logs. So it's very easy we think if a user does not tell us explicitly that something was wrong, they were happy with the answer. Now, of course, from that perspective, there's probably marginal improvements we could do, but this is where we would still have surveys where we collect more additional feedback also on things that went positive. But for the application itself, we really just focused on kind of the negative answers, but we can in the background, make sure that what is positive versus negative. But yeah, it's a good question. We debated a lot about this. That's why I was laughing ultimately when the question came. There's pros and cons, but yeah, we went for that.
Thanks.
So Microsoft also have a kind of an off-the-shelf offering. I believe it's called Chat with Your Data. Considering that many companies have more or less the same demand that you just provided, what made you decide to come up with a customized solution?
Sorry, can you repeat the last bit, please?
Why did you develop a customized solution in contrast to basically using off-the-shelf what's out there?
So I would say it's partly off-the-shelf, partly not. Typically, for the retrieval part, it's not. It's really off-the-shelf. So what we have to understand is really the algorithm behind to tune the parameters. So this typically we didn't spend much time on this. I would say the really important part where we should spend time is on what differentiates yourself from your competitors, which is data. Chunking the data is really the crucial part, especially when it comes to table data.
Maybe one more additional point on that. When we kicked off working on LifeGuide Scout, that was that was last year. Sometimes when the initial ideation phase happens, a lot of like the off-the-shelf or even Copilot, you could argue, could that do the job? Now, what we experienced with some of these off-the-shelf tools, you limited in terms of capacity, where we, with the customer-enabled tool, we can control that. So we have, for example, in Life Guide, we have, 6,000 pages that we embed or index that we can search for, which is very different with some of the off-the-shelf. But I'm sure this will change over time.
Maybe one point on this, having this, our customized approach, this microservice architecture, you can easily replace blocks. So typically, the models are the new LLMs are being released very quickly, while we can easily plug our own updated version. So I think it's also a way to be very flexible, to own the solution. And it's not that complicated. We're not DeepMind or OpenAI, so I think it's really worth doing it ourselves.
Maybe one more question from the back. I saw some questions there in the back.
Thank you. You were talking earlier about that latency for the application is very important, but I was wondering what is the most important metric in regards to evaluating the content that is generated?
I would go for the human evaluation, meaning we have feedback forms. I would say the satisfaction rate of the user.
So when you're
that's probably what the business is looking at. So
when you evaluate a new model, you first release it to a beta group and see whether that's better?
We have internal users, and that's definitely from where we take the feedback before releasing to outside. Yep.
Thank you.
Very good. Thanks a lot. If there are no more questions, thank you very much, Luis and Robert, for this very interesting talk. Thank you. Merci beaucoup. Thanks a lot.